Hi, this video will cover part A of the first question, graphing polynomial function. So let's go ahead and look at how we're going to sketch the graph of this function. So the first thing that's asked is, and the important thing to look for is, what is the degree of this polynomial? So how do we determine the degree? Well, we can see that our equation is in factored form. And so if we were to multiply this x times x times x, we would end up with x cubed. So x cubed is a degree 3 polynomial. Now, why is this important? Because if we know this is a degree 3 polynomial, we should know the shape. If you remember, a cubic function is a snake-like shape. So if I make a little sketch here, it will look something like this. Now, what happens in the middle depends on the number of roots or the number of x-intercepts. So let's go ahead and look at the x-intercepts. The polynomial is already in factored form, so that's very useful. When it is in factored form, then we can use the zero product property and set each factor equal to 0. So our first factor is x plus 1. If we set that equal to 0, then you can see that we have an intercept at x equals -1. So this is just solving for this equation. So we have an intercept at -1. And then if we do the same thing for x minus 2, we have an intercept at +2. And then we also have an intercept at +4. So we have that our intercepts are x equals 4, 2, and -1. We can already place those points on the graph. So I'm going to go ahead and place -1 on the graph, +2 on the graph, and +4 on the graph. What would be useful is to find another point such as the y-intercept. So how do we find a y-intercept? A y-intercept is when x equals 0. So if I plug in 0 into our equation, we can find out what y is. So what do I mean by plug in 0? Plug in 0 for x. So using this equation, I'm just going to write that y equals 0 plus 1, 0 minus 2, and 0 minus 4. Next, we will simplify. 0 plus 1 is just 1. 0 minus 2, this is 1. Let me change that color. 0 plus 1 is 1. 0 minus 2, so it's going to be 1 times 0 minus 2 is -2. And 0 minus 4 is -4. When you multiply these three factors together, you get +8. So our y-intercept is at 8. Let's go ahead and sketch that point right up here. Once we have these points, we can make a sketch of a graph. Now remember, it is a sketch, so it's not exact. Let's look at what I graphed here before. It's a snake-like shape. The important thing is where we start. In other words, we will talk about the end behavior. So when we want to draw this, I'm going to start from the bottom. We can see it starts from the bottom, moves away its way upwards. So I'm going to go ahead and start from the bottom. I'm going to go through the first intercept, which is -1. I'm going to go up to +8, which is a y-intercept. I'm going to come down to 2. And then I'm going to go up through 4. Now, remember what I said. This is just a sketch. It's not an accurate graph. So the reason I'm saying this is because how low you go here, if you want to know how low to go, you would have to input other points or use some graphing calculator. All right, so this is basically a sketch of the graph. We could even actually enter the point x equals 3. So if you entered 3 here, and if you entered 3 here, and 3 here, we want to know how low to go here. So 3 plus 1 is 4, 3 minus 2 is 1, and 3 minus 4 is minus 1. Multiply all these numbers, we get negative 4. So actually, at 3, we can go down to 4. So if I erase this over here, I can just draw it a little bit more accurately. So at 3, when x is 3, y is negative 4. So there we go. All right, the last thing we want to talk about for this graph is the end behavior. And so just like the word specifies, that's what happens at either ends of the graph. So let me go ahead and show you what the ends are. So we have one end here on the left, and we have one end here on the right. So the way, as I mentioned in class, we want to talk about this is we want to say what happens to y as x goes to the left, and what happens to y as x goes to the right. So we're going to say as x goes to the left, x, this is a symbol for goes to. Now instead of saying left, we could say negative infinity. So anything going in this direction is negative infinity. So as we go to the left, y is coming down. So as x goes to the left, y goes down, which would also be negative infinity. And then we would say what happens on the right. So on the right, as x goes to positive infinity, which means right, well, we could see that y goes up. Well, what is up when we want to talk about symbols? Y goes to positive infinity. And that's pretty much how you would describe the end behavior.